Alright, welcome to a video that's going to look at some steps to graphing a parabola in standard form. So a parabola in standard form is something of the form y equals ax squared plus bx plus c, where a is the coefficient in front of the squared term, b is the coefficient in front of the x term, and c is a constant. So those will all be filled in with real numbers. So the very first thing we want to find is the vertex. So recall that in a parabola, if a parabola is opening up, that's a terrible looking parabola, okay, it's going to be right there. And so the vertex is the point at which the parabola starts to change direction. If the parabola opens up, it'll be the lowest point. If the parabola opens down, then it will be the highest point. So this is known as the minimum, and this is known as the maximum. Okay, so how do we find that? Well, the x-coordinate, there's a formula that we use. It's negative b divided by 2 times a. Now, this is going to give you the x part of the vertex. So the vertex is a point, x comma something. So that something is the y. So to find that y, so that's step 2, find the y-coordinate of the vertex. To do this by plugging in the x-coordinate into the original function. So let's do an example. So at the bottom of this page there's an example of f of x is equal to 2x squared minus 4x minus 6. So let's start by writing down what a, b, and c are in this problem. So why don't you pause the video and see if you can figure out what a, b, and c are. And when you think you know, go ahead and unpause the video. Okay, so a is the x, or the coefficient of the x squared, which is 2. Now, not the x squared, but just the 2. Okay? So a is going to be 2. B is a negative 4. And we do want to keep that negative with it. And finally, c is a negative 6. It is the constant term, and again we keep the negative with it. So if you see a subtraction sign, make sure to include that number as a negative. So our formula for the vertex is x equals negative b over 2a. So plugging in our numbers, we have negative, and then b is negative 4. So those two negatives are going to turn into positives, over 2 times a, which is 2. So we have positive 4 over positive 4, which gives us 1. So now we have to find the y-coordinate, or in this case we're using f of x notation, but it's the same idea. So we need to plug in f with 1. Okay, so wherever I see an x, I'm going to plug in the number I just found for the x-coordinate of the vertex, which is 1. So 2 times 1 squared minus 4 times 1 minus 6. Make sure to use the order of operations here, which means do the exponents before the multiplication. So for example, I need to square 1, which is 1, and then I need to multiply it times 2. So 2 times 1 is 2. Here I can multiply, that gives me negative 4 minus 6, which is going to give me negative 8. So that gives me a vertex of 1 comma negative 8. So the vertex is 1, negative 8, and so we can go ahead and plot that on our graph. So over 1, down 8, 1, 2, 3, 5, 6, 7, 8. Okay, so let's go up to the next steps. The next thing you really want to consider is which way does the graph open? Does it open up or down? So we know that we have to look at the sign of a. So if a is greater than 0, in other words it's positive, your graph is going to open up. If a is less than 0, in other words it's negative, then the graph is going to open down. So if it opens up, it's positive, it's happy. If it's negative, it's going to open down, it's sad. Okay, so the next thing we want to do is plot our vertex, which, well, we already did that, but we also want to draw an axis of symmetry. The axis of symmetry goes through that point, the vertex. And we also can use it to help us remind ourselves what direction our graph is going to open. Okay, so I know my graph is going to go up, and so my axis of symmetry is going to go up. So I'm going to make a dotted line going up at this point, which is our vertex. And that just helps me remember that to make it go up. All right, going back up to our steps. Now this is considered an optional step because sometimes this doesn't result in a new point. It might result in a point you already have. For example, if the parabola's vertex is on the y-axis, but we can plot the y-intercept. So the y-intercept is always what you get when you let x be 0. So let's think about that for a second. If I let all these x's be 0, I'd have a times 0 squared plus b times 0 plus c. Well, we know anything times 0 is 0, so that turns into 0, that turns into 0, so I have 0 plus c, which is just c. And so c, even though it wasn't in the vertex formula, is a helpful way of finding the y-intercept. C is the y-intercept. Okay, so we can always use 0c. Now this may be the same as the vertex, and that's why I say this might be helpful. Or it may not even fit on the graph, but it's a helpful point. So in our example, our c is this -6, and so my y-intercept is over 0, down 6. So we can use that. That's going to fit on our graph. So 0, 1, 2, 3, 4, 5, 6 is right here. Okay, now that is a point on the graph. We can also reflect that point. So the axis of symmetry acts as a mirror that reflects all points from one side to the other. And so I count how many spaces away is the point. It's one space away, and I go that same amount on the other side, and so I can reflect that point right here. Okay. Now, sometimes that may be enough to give you the shape of the graph. When you do your homework in Math Excel, that's probably going to be enough. But let's say that the y-intercept is not a good point, it doesn't fit on your graph, or maybe you just need another point. In that case, just pick a point. Pick an x value and make this a small t table. Okay, so think about where you want it to go. For example, I know where this point goes. Maybe I'll pick the next one over, which is 3. You don't want to go too far away from your axis of symmetry, like you don't want to pick like 9 or something, because it's going to probably be way off your graph. So I stick close to the axis of symmetry. So I'm going to go ahead and plug in 3. So just like I did for the vertex here, when I was plugging in 1, I'm going to do the same idea. I'm going to plug in 3. So just to save room here, if you have room, you can do this completely separately. But just to save room, I'm going to plug in 3 for my function. Alright, so after I plug it in, I got that it was equal to 0. And so I have the point 3, 0. So that is actually an x-intercept, or a 0 of the function. And I can reflect that point, so it's 2 spaces away. I'm going to reflect it on the other side, and there we go. So now we have a parabola. So now we can connect. Actually, let's fill in what we just did here. Number 7 is we reflect any points across the axis of symmetry, and then we can connect the points with a curve. And it is curved, okay? Alright, you'll have to forgive my terrible parabola drawing. This is not as good as it should look, but it is difficult to draw it with the technology I'm using right now, but that's pretty much it. All right, in the next video we're going to talk about how to find the domain and the range of these functions. So stay tuned for part 2.